Okay, we have here today another integral from MIT 2025, regular season number 7. We have the integral from 0 to 2025, the fractional part of square root of x dx. Okay, this is my second video on this one. In the other one, we did this with a u substitution. I want to do a different method because that one was kind of like number crunching intensive. And so we do it a different method, we get kind of a different path. So to start with it, what I want to look at is just what is this fractional part. So if you have a decimal integer, I think in the last video we used 2.31, the fractional part is just going to return this part right here. So it would just return 0.31. And what we can do is use this definition for the fractional part of x. We can use x minus floor function of x. The reason this works, if you take like this number 2.31, well, the floor function rounds it down. So if you did 2.31 minus 2, you get back to this. So in this somewhat alternative method, instead of doing a u substitution, we'll go right away to use this instead. So we're going from 0 to 2025, break it up as x minus floor function of x dx. But of course, the thing I forgot is this is a square root. I've done that multiple times. So we've got the square root of x inside for both these. So what I want to do, normally in a lot of these problems, what I like to do is break it up on integer bounds. But where the important points are going to be is perfect squares because we have the square root here. So like if we were to just write this out all the way to 2025, we would go from 0 to 1 because 1's a perfect square. And then like in the next one, we would go from 1 to 4 and 4 to 9, etc., right? Doing this all the way to 2025. But instead of writing it out, we can do this as a summation, just summing up all those integrals. It's actually going to be, I think, 45 integrals, or is it 46? I can't remember, something like that. But we can do it as a summation, doing this, creating a sum from n equals 0 to 44. The reason why it's 44 and not 45, we'll see in a second. And then each of these, it's going to be an integral where we can make the lower bound n squared. So notice at 0, we're starting at 0 to n plus 1 squared. Because at our upper limit, if you look at 44, it's going to be 44 squared, which is 1936. And then the upper bound, 45 squared, is 2025. So then with our integral, reducing this, the square root of x is just going to be square root of x. So we're going to leave that. This one's going to reduce though. You picture, again, if you picture some integral, like if we just pick a random one, if this is like 23 squared to 24 squared, and if we're just looking at the floor of the square root of x, what's going to happen is the input here is going to be between 23 and 24, but the floor is going to round us to 24. Sorry, the floor is going to round us down to 23, this lower bound. So this value right here is just going to be an n. But what that's going to let me do, this is just something we can integrate. N's just a constant, square root of x is just power rule. So we'll go ahead and integrate this inside the sum. So looking at square root of x as x to the 1/2, I can do this as integrating this to x to the 3/2 with the 2/3 in front. This right here just becomes minus nx evaluated from n plus 1 squared, from n squared to n plus 1 squared. We'll go ahead and evaluate it. I think what I'm going to do, let's pull a 1/3 out just because I don't like having a fraction there. So if I pull 1/3 out of this, and then we start to plug in, we have 2 n plus 1 squared to the 3/2, that becomes n plus 1 cubed now. I have a minus 3n because I took the 1/3 out, so minus 3n, and we plug in n plus 1 squared. This is just going to be an n plus 1 squared here. Minus, plug in n squared, we'll have this 2 again. N squared to the 3/2, it's just n cubed. Plug in n squared here, but we still have that 3, so this is going to become minus 3n cubed right here. Cleaning this part up, we're going to have minus n cubed, but minus times minus is plus, so I can write this here as a plus n cubed. But now for this thing, let me clean up the board and see if we can just finish this off. And then from here, just multiplying everything out, we get all kinds of cancellation. 2n cubed plus n cubed minus 3n cubed. All that stuff's going to cancel there. 6n squared minus 6n squared. That's going to cancel here. I could take 6n minus 3n, and what we've got left in our sum is just going to be 3n plus 2. But now I can just multiply the 1/3 back in and break this up into two sums. So we have the first one's just going to be an n, and then the second one is just going to be 2/3. Well, this one right here, I can actually start it at 1, because when n's 0, it's just 0. So if we started at 1, what we have here is the first 44 natural numbers. So this formula is going to be 44 times 45 over 2. And then this one, it's just a constant, so it's just the number of terms. So it's going to be 45 times 2 over 3. Simplify this. This is going to cancel and give 22. Thinking of it as 2 times 11 times 45, 90 times 11, 990, plus here, cancel this and get a 15 plus 30. And for my final solution on this, we get just 1020, and that's it. Okay, there you go. Another one from MIT 2025. Thanks everyone for watching. Have a good day.